Okay, very welcome then to this webinar on how to handle scrubber waste. Very sorry that we are a little delayed here. This with the IT technology, it's always a little difficult, I think. Anyhow, we are going today to present to you some findings that we have from our project, Scrubbers Closing the Loop, and with the main focus on how to take care of scrubber waste and also what the scrubber waste really is and the environmental impact from it and so on. And we will start with a short introduction from myself. My name is Per Stefensson here at Stena Teknik in Gothenburg. And together with me, I have here Hulda Winnes on the other side. Hulda comes from IVL, Swedish Environmental Research Institute. And Hulda is going to tell us about the scrubber environmental performance. She's been doing measurements and tests of scrubber water and so on. And then we will go over to Southampton. Oh, I didn't say that Björn Asplind also here at Stena Teknik. He will give us a technical description of the scrubber installation so that you have a little background of our scrubber project here. And then we will walk over to Southampton. And there Gildis Williams and Andy Wright from Lloyd's Register, they will tell us about guidance on scrubber waste management. And during the whole thing here, you are welcome to chat or write your questions. It should appear somehow, I think. I asked Matthias, who is our technical expert here. It appears on the right side?
Yeah.
Right?
If you have a colleague watching a stream that isn't visible, please just inform them to click the link in the email again. It's the same link. It will give you like a new YouTube page. Then this one will be live.
Yeah. So there was some error there before. So you can write your questions there, and then after our sessions here, we will look at the questions and see if we can find something that we can answer. So if we start like that, first of all, I have to give you the so to say the obligatory part of it. It's that this is a co-financed European project, and then of course we have those different activities or work packages, if you want. And so this is the structure of the project, and we've been running this since the 21st of April 2014 and until now. In the beginning of the project, it was mainly port efficiency projects that we were doing, because of course we are also connected to ports. We are talking about the two ships, Stena Britannica and Stena Hollandica, and they are running between Hoek van Holland in Rotterdam and over to Harwich in UK. So we have been doing also within this project some efficiency works in both ports there. But today we are going to talk about the scrubbers, and the scrubbers is, as I said, on Stena Britannica and Stena Hollandica, and we've been doing installations there with closed loop scrubbers. And then in connection with this and within this project, we are looking into, I call it the soft parts of the project, and that is to do the technical analysis and so on. Because we learned at least that 2015, 2016, when we were doing this, there was not much knowledge actually about what is in the scrubber water, really what is the scrubbers doing, and so on. So we have been putting quite a lot of efforts into this also. As you can see here, Hulda will tell us about the measurement campaigns and the analysis of data, and then we have also done the life cycle analysis and the cost benefit analysis. But we are not going so deep into this today, I think. The next activity, that was the development of the guidelines for ship and shore, and we will hear more about that from Lloyd's Register later on. And we have something also that is the dissemination part of this, and that is what we call the Scrubber Observatory Platform. And that is, we have so far had two conferences where we have been discussing and presenting our results so far. And this is, you could say, the third conference, but this time it is a little more connected to what we call SME training North and South of Europe. And that was, I think, when we wrote the proposal to this project, it was very much a buzzword, this, you know, the SME training and so on. And the idea we had there was that, well, we in the northern part of Europe, within the SECA area, we have to start with this, with the scrubbers and so on. And then at 2020, of course, the rest of Europe and the rest of the world will also have sulfur limits. And then it would be reasonable that we that are collecting experience already, that we share that with other partners, so to say. So that's the reason why we have this work package. And I would say that this is what we are doing right now, since we are doing a cost-effective way of doing a conference right now. So in that sense, it's available for everybody. You don't have to make expensive travels and so on. We have some other activities also, but the single window port reporting system, that is unfortunately on hold because of political reasons within the European Union. The port efficiency I told you, but that is really not with scrubbers, so we leave that. And then of course you always have some horizontal activities. I will leave it by that, and then I will give the word to Björn, who will introduce us into the magic of our scrubber installations. Thank you.
Ska jag stå på filmen?
Nej, inte ännu. Nu ska Björn göra det här. Så.
Okay, thank you, Per. As said, Björn Asplind from Snöteknik as well. And I'm here to tell you a little bit about what we've done and why we've chosen to do what we have in this project. And just to give you a little bit of background to where Stena are in the sort of scrubber installation project way, and we have so far converted 7 vessels, sorry, 1, 2, 3, 4, 5, 6, 7, 8 vessels by now with scrubbers for Stena Line. They are all closed loop scrubbers, and today we are going to talk about the Stena Hollandica and the Britannica case mostly, which has then been co-financed by the European Union. First, just some pictures to give a little bit of flavor about what it is to install a scrubber, the size of the equipment, and what we're talking about is really a huge amount of plumbing. Pipeworks is an essential part of installing scrubbers, as you can see. Just to give you the idea, so first let me tell you what we're not doing in this project, as it's called closing the loop. We've not been installing an open loop scrubber, but I need to tell, for those of you who may not know how it works, I'll just give you that for reference. So in an open loop scrubber, we take seawater in, and basically you spray it over the exhaust coming from the engine, and then you drain that water out, and by that method you scrub the SO2 and SO3 emissions more or less out of the flue gas and some other things that come with in the process, like soot. They're also washed then overboard, and which is completely within the regulations. In some cases, there is a water treatment plant installed to clean the effluent water before discharge overboard, but in most cases, I would say it's not installed in the larger number of ships today. The open loop scrubber works on the principle that it's using the alkalinity of the seawater and discharging a low pH acidus effluent into the water. Looking at the closed loop scrubber, we have a little bit different situation in our case than what we do is then, as it sounds, we are circulating the scrubber water in a closed system that then accumulates sulfates, the sulfur that's washed out of the exhaust stream, and that is why we need to take part of that water out every now and then or continuously and take it through a cleaning process and then discharge a smaller amount of water with sulfates overboard. In order for the closed loop system to work, we need then to add an alkaline as that is consumed in the process. In most cases, it's sodium hydroxide, caustic soda. We started off doing that. We have actually now shifted to magnesium hydroxide in these ships just recently, which works in principle in the same way in the scrubber process. And the main difference here between the open loop and the closed loop is then that we can implement a much better water treatment facility in this system, which is much more efficient than what you could do in the high flow region that you have in an open loop system. And we then also collect the sludge on board. I'll go more into detail with that later on in this system. Looking at what we collect, which is the sort of essential part here, is that we generate a sludge from the scrubber system, which will then be going onshore to a facility. We will show you a little bit more about that later, and that will end up in cement. In the end, what's left, the ashes, will be ending up in cement. What we see here on the picture to the left is a glass of the initial part of the sludge, where you see that we have a fraction that is heavy, which sinks to the bottom of the glass, which is separated out from the water. We have a top part here, which is floating up, which is lighter, so oily, which is also separated out. And the yellow portion here, the water containing sulfates, is discharged overboard. What we collect looks something like you see on the right two pictures here. It's relatively pasty mud that we collect. We usually refer to it as clay. And this is collected and disposed of ashore. And just to give you sort of the scale of this, we are collecting roughly 1% of the fuel we burn in the form of this clay and dispose of ashore. And for the 4 vessels that we have operating out of Van Holland, this is then in the neighborhood of 450 tons. We tend to run it a little bit more wet these days, so it's probably a little bit more, but it's water than contained in this. Well, here are the reaction formulas for the scrubbing process. I won't bore you with them really, but just to understand why we're going to the closed loop scrubber is that we thought that the open loop scrubber, well, that could contribute to the acidification of the sea, and there is no really efficient or effective way of cleaning the water from the other things that come with the process in form of particles, hydrocarbons, and heavy metals. So that's the sort of 2 negative things that we mainly see with the open loop, and which we could improve by implementing a closed loop system, is that we could then generate this sort of pH neutral effluent to the water, to the sea, and we could catch most of the particles and hydrocarbons before discharging anything to the water. Looking a little bit on the water cleaning system in a close-up, what we've implemented here is that we go to a dissolved air flotation unit. We take some of the water out from the scrubber water. We go through a dissolved air flotation unit, called it BOTU, and that then goes into a sludge tank. And here we typically have a water content in the sludge of about 90%. So only 10% solids in this tank. And then we go to a secondary step in the cleaning cycle. We go through a decantering system, which then takes more of the water out, and we end up with something that's about 30% solid in the sludge that we discharge up to a shore facility. And the other two then cleaned water streams, they go through a water monitoring system to make sure it's in compliance with regulations and is then discharged overboard. And this is just what the IMO says by clean. This is what we have to live up to according to the MARPOL regulations. So the turbidity should not be too high, the polarimetric hydrocarbon level is limited, and the pH needs to be above 6.5. And just to give you an idea about where we are with the sort of turbidity, which is the clearness of the water, we can see here on the scale here that we need to be below 25, which is somewhere around here. So it's relatively clear water. And again, this is the glass. This is typically what is discharged overboard, the yellow portion, the clear fraction is discharged overboard. Water monitoring is made through an extractive instrument. We've seen that we've had in these closed loop systems a little bit of problems with clogging of some of the pipes on occasions. That is a little bit of hassle to the crew. Otherwise, we think it's working pretty well. The exhaust gas, I mean, the primary function of the system is to reduce the SOx, SO2 emissions of the system, and we can see it does that very well. We should then be below 0.1 sulfur in fuel equivalents, which is measured to the relation between the sulfur dioxide and carbon dioxide in the exhaust stream, and that should be a measure that's maximum 4.3. And we, as you can see here in this occasion where I've taken a photo of the mimic panel, we are at 0.1, so well below regulatory limits on SO2 emissions from the system. And this is then measured in our case by a Consilium system, a light emitting system. That is a direct method of measuring through the exhaust gas stream in the exhaust pipe. So not an extractive method. So about the Stena Hollandica and the Britannica, they are two of the world's largest ferries. They have a total main engine power about 33.6 megawatts. They're capable of about 22 knots of speed. And they carry about 5.5 kilometers of freight, which amounts to about 320 truck and trailers. It's a four main engine arrangement with two larger and two smaller engines. And we are scrubbing only the main engines on these ships. The auxiliary engines and the boilers are running low sulfur fuel oil. And here you can see some of the dimensions and the capacities of the system. And you can see that the scrubbing water capacity on full load is about 1,800 cubic meters of water per hour circulating in this loop. Looking at the arrangement of the system, we have down in the basement, we have 4 circulating pumps that are supplying water through a pipe system up to the funnel and to 4 inline merciless scrubber units. Water is then sprayed over the exhaust, which is coming up through the pipes here, and is then drained down through large pipes down to a process water tank where it all starts all over again. So that's the main principle of the system. Well, this is the same thing, only from our 3D model. Just to give you a little bit of detail on the exhaust gas arrangement, we have in this case SCR units installed for reduction of NOx emissions. We have economizers, exhaust gas boilers, and then we have the scrubbers last in line, and that seems to work okay. On the Hollandica and the Britannica, the SCRs are currently not running. They probably will be in the near future, but at present they're not. We have other ships where they are running in combination with the scrubber successfully. And the main thing here is that we want the high temperature exhaust. We need that for the SCR to work properly. We then take some of the temperature of the exhaust out in the boilers, and then we go into the scrubbers, which are operating at a relatively low temperature. Scrubber installations was done at Damen shipyards in Rotterdam. We were 11 days in dry docks to do the installation. We had the scrubbers assembled in the units that went into the funnel as one piece to keep it as short as possible. And we then finalized the system in service, which was quite a bit of hassle, and I have to admit at some points making the final bits of the pipework and the final electrical installations. And here are some photos from the yard when we did the actual installation. And you can see how we started to build then the scrubbers into modules that went into this funnel module that was put on top. Everything was built according to a 3D model generated after 3D laser scanning. Otherwise, this would not have been possible to do in such a short period of time. Also, a lot of GRE piping was used, kilometers or hundreds of meters of GRE piping was used in the system. And here you can see a photo of what it looked like in the beginning of the installation when we took most of the pipes on board. Pumps are relatively large units installed in the port side fin stabilizer room on board. So just to sum up, we've installed a closed loop scrubber, which enables better water cleaning, we think, compared to open loop. We do not, with this system, contribute to the acidification of the sea, as we are adding an alkaline to the system. SOx emissions are removed well below regulatory limits, so we are better than changing to 0.1% fuel in that sense. And we are here collecting a significant amount of soot that can be handled by state-of-the-art processes on shore. And to give a little bit more detail about that, we have a movie to show you.
Yeah, that we will do it later. Yeah.
Hmm?
The movie will come a little later.
Yeah.
First, we will see the movie.
Okay, sorry.
With the installation. Yeah.
Sorry about that. So let's run the movie.
Yeah.
Yeah. Here we go.
It's February 25th, 2017. At Damen Ship Repair Rotterdam, a new guest is welcomed, the Stena Hollandica.
Stena Hollandica is one of our super ferries and is 240 meters long, 32 meters wide. Can take 1,200 passengers and 320 truck trailers. And then next to that, about 250 cars.
A lot of work needs to be done on the Hollandica before she sails off again in less than 2 weeks.
At the moment we're at the yard for conversion to scrubber installation in our funnels. And in the meantime we also take the time for a normal docking.
In the end, some of the most complex work on the Hollandica will hardly be visible. However, it is proof of Stena's commitment to a sustainable future.
We're installing here a scrubber installation. There's a big wash plant for the exhaust fumes and takes out the sulfur and fine particles that is normally blown into the air. We install a closed loop scrubber installation compared to an open loop scrubber, which is also possible. In our case, all the particles will be kept on board and then given ashore for recycling or reuse.
We have installed a variety of scrubber installations on different types of ships. Well, each individual project is unique for the scrubber installations. So we have experience in that. We really we can support the client with design and our experience from the installations.
It has been hard work, but only 12 days after she arrived, the Stena Hollandica is ready to leave Damen Ship Repair Rotterdam, freshly painted, serviced, and most important, ready to take passengers across the English Channel, more sustainable and in better comfort.
Okay, I hope that gave you a little idea about the sizes and what this really is all about when it comes to installation of scrubbers. It's quite amazing sizes of everything actually. So after that, I know that already some have been asking us about what is in the effluent water and so on. So I think that gives a good reason for Hulda to take over now and to tell us about the scrubbers from an environmental perspective.
Thank you.
And here you are.
Yeah, hello. Yes, so my name is Hulda Winnes. I'm with IVL, the Swedish Environmental Research Institute, and we are a team at IVL who has conducted environmental studies of the scrubber installations on Stena Britannica and Hollandica. And I will present some results and some conclusions of these studies today. This will be in a broader context than just the rest product or the sludge of the scrubbers. This will be also emissions to air and water. As a part of the larger project, this was an activity in itself, and we were 3 participating partners. It was us, it was Lloyd's Register, and Wärtsilä, and we did the work together with Stena, so we had some cooperation. And we split the work into 4 different parts. We have done air emission studies, and we've done water emission studies and toxicity tests. We've done a life cycle assessment and cost-benefit analysis. And I will briefly go into all of these today. Oh, sorry. Yes. So basically what's interesting from an environmental perspective is to compare the different alternatives that you can use on ships to comply with the SECA regulations. So this has been our aim in all of the different parts of our studies. And we've looked at low sulfur fuel oil as one of the options, and we compared it with using wet scrubbers on together with heavy fuel oil. And this will be just some briefs on the study setups in the different parts of the project. For emissions to air, we did some air emission measurements on Stena Britannica. We did 3 rounds. We did 1 test round on low sulfur fuel oil and another one on heavy fuel oil with and without the scrubber running. And let's see. We also took some samples on the solid waste from the scrubber and did some chemical analysis of the sludge. And for the water emissions and toxicity tests, we took several samples from both closed loop system and open loop systems, and did chemical analysis of the effluent waters on all of them. And from the system on Stena Britannica, we took samples at different parts during the process on board, so we could see also the efficiency of the system installed. On the effluents from open loop and closed loop scrubbers, we did ecotoxicity studies, and from these results we could do an environmental risk assessment. These data were then used in the other studies, the life cycle assessment and the cost-benefit analysis, together with external data from other sources. And in both of them, we did comparisons of the low sulfur fuel oil alternative and closed and open loop solutions. So I will start with going through the emissions for air studies. And as I said, we found it interesting from an environmental perspective to compare the different compliance alternatives, but from the measurements we did on heavy fuel oil, where we tested both upstream and downstream the scrubber, we could also say something about the reduction efficiency on emissions over the scrubber. I can also mention that when we did these tests, we tested several different steady state engine loads for comparison. Our main findings includes that air emissions of sulfur dioxide is significantly lower downstream the closed loop scrubber than at combustion of low sulfur fuel oil. We actually had a reduction over the scrubber of 99% or more at all instances. And this was even lower than what we had at the low sulfur fuel oil combustion. Our studies also showed that we had less particle emissions from the low sulfur fuel oil than at heavy fuel oil combustion downstream the scrubber. So at this instance, the low sulfur fuel oil had better performance than what we could see from the scrubber studies. We measured particle emissions by mass and could see that they are reduced over the scrubber with 34% and 42% at high and medium engine loads respectively. So we have a reduction of the scrubber, but it's not as efficient. It's not reducing emissions to a level comparable to those of low sulfur fuel oil. We also looked at different parts of the particles. We have solid particles and we have volatile particles. And the volatile particles are more easily affected by conditions in the surrounding environment. So if it's cold or warm, or the contents of volatile particles is very different. But when we have solid particles, they are quite constant, independent of atmospheric conditions or test conditions. We could see that a fraction of the solid particles remained downstream the scrubber, approximately 40%. An important aspect when discussing or talking about these particle emissions is that we have no standardized measurement methods that applies for particle measurements in cold exhaust gases, which would actually be quite useful now when more and more scrubbers are installed. All standardized measurement methods are applicable to hot exhaust gases, and that is quite different. These diagrams show emission factors of different gaseous compounds that we measured in the exhaust gases during the tests. We have color codes for the different sets of trials. So the greenish bars are on low sulfur fuel oil. The more yellowish kind is for heavy fuel oil upstream the scrubber, so without any treatment. And the bluish ones are downstream the scrubber. And you can see that, let's see here, carbon dioxide and nitrogen oxides are fairly unaffected by the scrubber. We can also see that the sulfur dioxide is very much reduced downstream the scrubber, as mentioned before. And these greenish ones are on the low sulfur fuel oil, which is also significantly less, of course, than the heavy fuel oil. We can see that carbon monoxide are reduced in the scrubber, but not to levels that we measure for the low sulfur fuel oil. We can also see that the polycyclic aromatic hydrocarbons that was mentioned previously, and that are a group of hydrocarbons that are known to have help to have carcinogenic effects, many of them. They are also reduced over the scrubber, although not as much as to the levels that you see from the low sulfur fuel oil combustion in our tests. However, for other hydrocarbons, we can see that the scrubber actually is quite efficient during reductions and takes them down to levels lower than the low sulfur fuel oil. And these are corresponding diagrams for particulate matter emission factors. We have here the particles by mass. And we can see, as I mentioned previously, that for the heavy fuel oil upstream, the scrubber, we see the highest emissions that are reduced somewhat in the scrubber, while the emissions we measured at the low sulfur fuel oil trials were even lower. As I mentioned previously, we also tried to distinguish between solid particulate matter and volatile particulate matter. And typically, solid matter are seen as the elemental carbon and black carbon, which indeed are very much related, and the metals in particles. And we see basically the same pattern here as for what we mentioned before for particles in general. We have a reduction in the scrubber, but the emissions we measure at the low sulfur fuel oil are actually even lower. More volatile parts of the particles are the organic carbon, where we see that the scrubber is actually quite efficient in this reduction. Okay, so as it comes to the sludge or from the bleed off treatment unit from Stena Britannica, I will just show you some results from the chemical analysis of it. Most of it is water, which is expected, but the solid material is mainly composed of ash and carbon. We also have some fractions of sulfur and chloride. The most abundant of the analyzed elements in the ash fraction is sodium, aluminum, silicon, and vanadium, which of course comes from the fuel to a large extent. If we did a very rough mass balance analysis for sulfur in the fuel, and we could see that the absolute majority of the sulfur from the fuel ends up in the effluent water. And as also mentioned, that is not acidic. It's since the acids are neutralized, approximately 10% ends up in the sludge, and 3% stays in exhausts as SOx or particulate-bound sulfur. I further have this one, but I don't think I will go into such detail. Now, concerning emissions to water and the toxicity tests, we did tests on effluent water from a closed loop system and also from open loop systems. Our main findings from these studies are that we see toxic effects on marine organisms that are exposed to scrubber effluent waters from both closed and open systems. We could also see that the toxicity could not be correlated to a specific substance in the water, but rather to the effluent water as a unit and its mix of substances. So the water as a whole proved toxic to the organisms exposed, but we could not relate it to specific substances, neither metals nor hydrocarbons in the water. We conducted a risk assessment based on the toxicity tests. And that pointed to that there are environmental reasons to be cautious concerning effluents from both open loop and closed loop scrubbers. I will tell you more about this later. And an important remark is, of course, that the open loop effluents comes with a higher risk than the effluents from the closed loop system, even though we saw risk with both of them. Yeah, so we've conducted toxicity tests, not me, but my colleagues, and what you do is that you use a set of containers in which you place organisms of a known amount, and you expose them to different concentrations, different known concentrations of the compound that you want to investigate the toxicity of. From this, you do time series, and you control your containers every day to see how many of the exposed animals that are affected. And it can be death that you look at, or it can be how often they molt their skins, or it can be many different things that you use as indicators for the functions of the marine organisms, in this case, that you use in your containers. And as this is done, of course, you will use replicates, and you will use reference containers as well, to be sure that what you see is an effect of the compound or water mix that you test. And we did this for, as I said, for the closed loop and the open loop system. We could see that even at the lowest tested concentrations, in all cases, we had an effect on the marine plankton that we used as test organism. We saw the effect at a higher concentration for open loop scrubbers, and that is because this water is much more diluted than from the closed loop system. So at exposure of 1% of scrubber water in seawater, we had significant effects on marine organisms. This is in the open loop tests, and from the closed loop tests, we saw effects at even lower concentrations in the test water. From these limits of concentrations, the lowest effect concentrations we found, we conducted a risk assessment. The way we did this is that we looked to the Water Framework Directive, who has guidelines for doing this. These guidelines is normally applied for discharges only in the absolute coastal area and for specific substances in an effluent water. So we use the methodology, but this is not a standardized set of risk assessments. We thought this was the most reasonable approach, and we used the lowest concentrations with an effect and a safety factor that gives a threshold value that should not be exceeded. We calculate a mixing zone, a water tunnel behind the ship, where this concentration can be exceeded according to the Water Framework Directive, but outside this area, we should not exceed this threshold level. So basically, this is all the modeling we do in this risk assessment, and that is, of course, kind of a blunt instrument. We should. This is something that should really be refined in future research. And as I said, in the mixing zone of the water tunnel behind the ship, we can exceed the concentration limits according to the directive, but we can also expect that if the water tunnel dimensions are increased, it's easy to see if the threshold levels are exceeded. And based on this, we could see that the scrubber effluent from one ship with an open system exceeds the calculated threshold concentrations by 6.3 times, and the closed system effluents by 1.9 to 3.8 times, which is, of course, something that calls for further modeling of these discharges in sensitive areas. And these are then based on the tests done on the zooplankton that we tested, did use for our toxicity tests. Okay, I will show you some very brief results from the life cycle assessment and the cost-benefit analysis as well. For these studies, we compared low sulfur fuel oil and with heavy fuel oil and a closed loop scrubber, and heavy fuel oil and an open loop scrubber. And these are the main findings from the life cycle assessment, and not very controversially, the operational phase and mainly contributes more than the construction and scrapping phase to environmental impacts. Of the three systems that are compared, the differences in total energy needs are small but slightly in favor of the low sulfur fuel alternative. And that is simply because we use extra energy on board to run the pumps and the cooling of the process water. And we could also see that all other impact categories except elemental depletion are in slight favor of the low sulfur fuel alternative. But the differences from these studies show very limited differences between the different alternatives, actually. For the cost-benefit analysis, where we look at external costs from emissions to air and water, we could see that the effects from emissions to air are dominating the external costs. And that is, since more energy is needed for the studied closed loop system than for the open loop system, external costs from a closed loop system are higher than from an open loop system in our cases. Once again, the differences between the systems are very small, and there are uncertainties in these kinds of studies. We also looked at external costs from emissions to water, but those are seldom evaluated and are therefore difficult to compare with costs for emissions to air. We could see that the open scrubber system has higher external costs for water emissions than the other two options. And like I said, the differences are very small. And we could see from an uncertainty analysis that from an external cost perspective, the low sulfur fuel oil alternative is beneficial compared to HFO and closed loop scrubber system, but when the open loop is not tested. Okay, thank you.
Thank you very much, Hulda. Well, that's a lot of information.
I know.
And just so that you know that everything of this will be up on our webpage afterwards. We will both record the whole seminar or webinar, and then we will also have all the presentations on our webpage. And the webpage is very simple. It's stenatechnik.com. So that should be quite easy for you to remember. I think now that we should give the word to our British partners at Lloyd's Register in Southampton. So Yildiz and Andy, welcome to the webinar. Sorry.
Maybe they can see it.
Hello.
Hello.
Hello there.
Yes.
Hi. Can you
Good
hear
afternoon
us?
from Southampton.
We can hear you.
Okay, great. So, Welcome to Lloyd Register and welcome to our Global Technology Centre. I'm here, my name is Yildiz Williams and I'm here with my colleague Andy Wright. We will present Lloyd Register's work on the Closing the Loop project. And we will do it as a team because we've completed the work as a team. So I'll start with a few of the slides and then Andy will help me out as well. I'm hoping that everyone can see our slides because yes, you can. Excellent. Okay, so I just wanted to give you a little bit of background of our work from the whole Closing the Loop project. So as part of the development of these guidelines, we, Lloyd Register, has visited 2 Stena ships sailing between Harwich and Hook of Holland, as Per mentioned. And these ships were Stena Britannica and Stena Hollandica. They're both ro-ro vessels, and they're classed with Lloyd Register. So we've, as Lloyd Register, also completed class statutory and installation approvals for those vessels during the installation of exhaust gas cleaning systems. And the systems installed on board these ships are, as mentioned by our colleagues from Stena Line, are Wärtsilä closed loop systems for their 4 main engines. What I like to also mention that we, the colleagues that completed the guidelines, we work for the consultancy part of our business, so non-class part of our business, to make sure that we ensure that third-party independent work. And that's the background, very, very high level. I'll move on to the application of the guidelines. So who does that apply to? Although we prepared the guidelines based on the experience and information that we gathered on board these 2 Stena ships, we try to develop them in a way that they are generic and they could be applied to all sorts of different vessels and make use of different types of exhaust gas cleaning systems, regardless of the ship's flag or type or its operational profile. So we hope that it will be beneficial to all industry. And we would also like to recognize and thank for the crew on board Stena Britannica and Stena Hollandica. During our visits, they've been very helpful, very hospitable, very open, which was great, and very patient with us. So thank you for that. And we also want to thank the Stena Line shore staff. Again, they've been very open and honest with us and very hospitable, so that during the risk assessment especially, we had a lot of input from their experience. So thank you. So now I'll move on to what is actually within the guidelines. We start the guidelines with a general information about exhaust gas cleaning systems, looking into open, closed and hybrid type of systems, and give them high-level understanding how these systems work. So it doesn't necessarily focus on what we've seen on board Stena ships. And then we have a section about consumable management, because although the guidelines, always we refer it as waste management guidelines, there is a lot of consumables that's also a very important part of the guidelines. So there is a whole section about consumables used on board and their description, loading, discharge, and obviously handling of these consumables is a very important part of the guidelines. Another part also very important is obviously the waste, how it's managed, and which type of waste we're talking about, mainly effluent and sludge. And again, the guidelines provides that information to the user in terms of what is the waste, how it could be stored and discharged appropriately, and provides that high-level input. Then it covers areas in terms of port reception facilities and provides some guidance towards the port reception facilities in terms of how they can manage both consumables and waste that they have to have on their facilities, on their site. There is also an important section, what we call the operations on board. So this doesn't necessarily mean how to use an exhaust gas cleaning system, but it's mostly looking at it from a consumable and waste aspect, but it's not necessarily just loading and storing and discharging of these chemicals, but also everyday operations that the crew have and the challenges that they face and how we can actually assist them towards those challenges. And again, very important part, which is training and information, how the stakeholders can arrange training, how they can make it suitable for their purposes, and how can they share information to make it a better environment. So this is very high level, but I think it's a good insight of what does the guidelines have within. So now I'll ask my colleague Andy to carry on.
Good afternoon, everybody. So, going down to the actual consumables that we have on the system, such as the closed loop scrubber, the primary one is the alkali. As Per has already and Bjorn have already described, this is the major input onto this system. Now, since in this instance we use 50% aqueous solution of sodium hydroxide, this is a pretty hazardous material in itself. It has to be recognized. This is not a material that people are used to handling in bulk quantities within the engine room system. As we see here on the top right there, this is actually loaded on the vehicle decks from a road tanker. It's a complete road tanker's worth, 20 tons, 30 cubic meters delivered at a time. Now, obviously, the type of ship that we're involved here has the great benefit that the tanker can drive on. It can drive into a, if you like, a protected, safe environment. We have to recognise that in a general purpose, loading may take place ex-dockside. It may even be some delay between the actual delivery of caustic soda to the port and it's loaded onto the ship. So in this instance, we've got a very, should we say, straightforward situation. You see there the specially coloured hose fitting onto an already existing tankage connection within the ship. The ship had 2 spare tanks from a previous activity that could be dedicated to the closed loop scrubber, one for storage and one as the process tank. Many other ships, in looking at taking on board a closed loop scrubber system such as this, will need to develop their own tankage arrangements, whether that's in the engine room or adjacent to the engine room or adjacent to the loading station is a point to be sought out in individual cases. Of course, what we just missed from the picture in this instance is the safety equipment, the stand shower arrangements, washdown arrangements, and behind where we're looking from in this instance, the spill bin that would be used in the event that there was a leakage, a spillage during the loading operation. Storing on board, as I say, in this instance, there's 2 tanks or 1 tank that could be dedicated to this particular task. Other installations will have to make their own dedicated arrangement for that instance. Use, we have circulating caustic soda around the system, both as Per showed in the direct injection into the scrubbing loop, the wash water loop, and also a smaller line that goes off to the bleed off treatment unit to ensure that we've got neutralized effluent that goes off the ship at the end of the day. Point with that is we've got pipelines running around the engine room with a toxic, dangerous material in them, and they have to be duly marked up, duly labelled, and due caution applied when moving any other equipment around the engine room. So that's the bulk consumable, if you like. Our next one is, in this instance, the coagulant. This, as we see, loaded in IBCs, 1 meter cubic tanks, and it has a dedicated tank itself on the vehicle deck. Again, a material that needs to be handled with due caution, pH less than 3, so a highly acidic type material. This is used down on the bleed off treatment unit, so again, this has to be piped from the vehicle deck down to the unit itself. We've got the loading of it from these tanks, these IBC tanks, through. If you look at the installed tank there on the ship side, you may see to the left of it, there's a small pump with a hose, trailing hose, and that's dropped into the tank, and in this instance, pumped up into there in order to unload that IBC into the tank itself. At the end of the process, of course, is down in the bleed-off treatment unit, and due caution always needing to be applied there whenever work is undertaken on that particular piece of device. And neatly finishing off in this instance, we have the flocculant. So we've had the alkali come on road tanker, we've had the coagulant come on in the IBCs, and the flocculant comes on in these 25 kilo drums. So we've got all range of sizes of consumable, handleable that are being presented to us, and which provide very useful input to the guidelines themselves. This, we've got the issue of handling 25 kilo drums, loading them down into a safe and stable storage area within the engine room, moving them to the point of use, and their actual load up onto the bleed-off treatment unit. So again, an item highly acidic and not the sort of stuff to be lightly played with. As you see on the side of the label, standard toxic or corrosive material label, and the symbol on the right, the corrosion of the hand, is indeed very applicable to such materials. So due caution all the way through the system. We also have some other chemicals on board, the calibration checks on the effluent monitoring, for the pH sensor, for the turbidity sensor and for the pH sensor. And also we may have test gases for the exhaust gas monitoring device as well. So each of these has to be handled, taken care of in accordance with the MSDS, which we supply with that product at the time of delivery, both for the folk on board and for other folk who would come into contact with that in the course of their business on the ship or indeed within the port area. So we've got effectively there the 4 streams of consumables coming on to the system. So I'll now hand back to Yildiz for the waste management side of things.
Thank you, Andy. So Andy has covered the consumables. So I'll move on to waste management. So this is now, the waste is coming from the exhaust gas cleaning system. So we divide that into 2 bits, effluent and there is the sludge, as mentioned before. Thankfully for the effluent, IMO has worked hard and we have a set of guidelines, MEPC 25968. So that guidelines place emission limits on effluent discharge, providing the emission limit values are satisfied. They allow for exhaust gas cleaning system to operate while discharging effluent to sea with no further restrictions. However, obviously, there may be additional national and regional local restrictions that would apply, so that due care must be definitely taken into account. So in terms of an open loop exhaust gas cleaning system, the effluent may be treated and will be diluted before discharge to sea. For a closed loop exhaust gas cleaning system, which would require bleed off from the circulated wash water, and after treatment may be discharged to sea. However, the bleed off rate can be low enough for this to be temporarily retained in holding tanks for later discharge to sea or a suitable reception facility landing ashore. So effluent part is still mentioned within the guidelines, but it is actually covered by the IMO MEPC 25968. I'll move on to sludge, which is the part that we are mostly interested when we talking about waste of exhaust gas cleaning systems. So we've got interesting images from the ships that we visited. So the waste generated from exhaust gas cleaning system is categorized to be harmful to the marine environment. Therefore, it's incineration on board or discharge to sea is prohibited, with there is no exception for this. Within the guidelines, we provide certain elements in terms of how they shall be stored on board and how they shall be discharged as well. There will be a small video from Stena Line. I've seen it with Per yesterday. That will also give you some insight of the discharge processes. So that will be interesting after our presentation.
Okay.
I think this is
Yes, so I'll just take over on the section on board, because of course the major thing with any such guideline as this is got to engage with the people on board. Crew, ships engineers these days are faced with ever more complex and new systems being loaded onto the ships, and systems which they don't have, frankly, any past experience. And so there's got to be an engagement and a training process in order to take that equipment on board. How the system is actually operated and the monitoring systems that go along with it, in how to handle, how to repair, how to maintain the system. Both to show proper performance at the time of surveys, surveys for the MARPOL Annex 6 certification, and of course such equipment as exhaust gas cleaning systems is very likely to be quite a point of focus of port state control inspections to see that this alternative equivalent means that's been allowed on board does indeed function, as in functioning effectively and safely on board. Now, largely in this presentation, we've been talking about an operating ship. But of course, we have to take into account, and our guidelines have looked at this, what happens in emergency situations. For example, do we have a situation where we have a massive breakage of a caustic soda pipe, for example, within a ship? And in terms of non-standard operations, these ships, as we've said, shuttle backwards and forwards between Harwich and Hook of Holland. But of course, in this instance, they go for periodic docking. In a docking situation, you've got potentially caustic soda on board, a whole heap of dockyard crew on board, or riding crew on a ship that need to understand that there are pieces of pipework, pieces of tankage on board which do not contain the typical engine room type fluids. As we put on the side here, what happens in the should we say, the pass on of knowledge? We often see that the initial crew have a reasonable degree of training, or at least handover from the suppliers in the first instance. But does that get diluted, or does it get augmented as it passes on from one crew to another? Is it truly passed on? Is it passed on with certain omissions, certain additions? So this is all part of the carry-on process. How to repair. We had in the picture there of the coagulant, the pump. When we were on board one of the ships, they'd had a problem with one of the pumps, for example. So the second engineer was working out how he was actually going to open up that pump, bearing in mind that it contains a fluid, as we showed there, quite acidic, low pH, or indeed the caustic soda pipe work if there's a leakage in the system. Obviously, in the ordinary way, if we're dealing with a saltwater, freshwater system, we have a material in the pipeline which represents no problem itself. It can even be drained down to the bilges or whatever else. If we're working with a lube oil or a fuel oil piping system, yes, we can contain it. But of course, if we're operating on a caustic soda piping, coagulant piping, flocculant part of the material, we've got a pretty hazardous material there that has to be contained and the actual equipment made good before we can start to get into it to do even our standard mechanical parts, mechanical repairs on it. So there are a number of challenges on board. These are certainly not insurmountable. These are certainly, as Stena's experience in this particular example has shown, things that the ship's crew, the ship's engineers will adapt to and hopefully take into part as their standard operational. But it does require application, it does require engagement.
So the next area we're going to talk about is port reception facilities. So the waste, land and ashore. So we're talking about sludge, and in this instance, when we were visiting the Stena Line ships and also the shore facilities, obviously they, as you can see from the pictures, the sludge skips to be stored securely within the port area. So this is just one of the things, that there are a number of elements that we make recommendations within the guidelines in terms of how the sludge skips should be stored, and also making the areas very clearly marked so that they cannot be mixed with any other waste. There needs to be a line so that it would ensure that they're not overfilled for spillage, to prevent any spillage. Also perhaps kept in areas that they don't get too much weather, like rainwater within, so that again the sludge becomes too wet during transport. That would then increase the risk of spillage due to its consistency. This is a set of guidelines that, like I mentioned before, is generic, but there will be very specific requirements on each port area. So we also recommend for operators, ship owners and operators, to make sure that they check the local requirements before they think about their journeys, so that whether they need to land these skips to different parts of the world, and they would be ensured that they would be able to land them, otherwise they need to be stored on board. One other thing is not only the waste, but in terms of talking about port reception, is also the consumables that is used on board. Again, depending on the operational profile of the vessel, that needs to be planned well, so that they can make sure those consumables are brought on board in the means that the ship needs to have it. So that's also part of the discussion within the guidelines. The next area we're going to talk about education, training and information. It's very, very important that how the training on board is developed, and how the crew on board is well trained to understand use of exhaust gas cleaning systems, but also to be able to handle all the consumables as well as the waste. So the training is certainly paramount. And that needs to be developed by each company so that it's specific to their ship, specific to the system on board, as well as the consumables and waste generated, consumable use and waste generated on board. There are some areas I want to make sure that I highlight, so I'll check my notes if that's okay. We always make it sure that the information is shared within the fleet. So that is a very good practice to make sure if certain lessons learned on one ship is applied to all others. So sharing that knowledge and information within fleet is very, very important, and it's a very good practice. So this is something that we highlighted within the guidelines. Placards is also something that a very important part of information and sharing information, so that when we have when the ship has this crew turnarounds, that it would ensure a consistent means of knowledge transfer. The placards should definitely be placed on places where the consumables are used and also stored, and same for the waste, wherever it is stored, and there should be enough information displayed for all the stakeholders to be able to understand. Any incidents occurred on board, so there will be incidents. We hope that they are not going to be too major, but if there is any incidents occurred on board, again, these should be recorded and also shared within the fleet to lessons learned, any improvements that could be applied to prevent any further incidents happening. Suitable work permit systems shall be applied within fleet, so that would ensure that personnel is well trained to be able to deal with the required consumables and handle waste necessarily. the communication is very important part of the education and training. So that needs to be done in a language that is understood by the crew, and also obviously if the information is shared by other crew in a suitable language that could be understood by all different stakeholders within. I think I covered Andy.
And of course, bear in mind that ships will be sold. To be sold with a full set of information from the seller to the buyer, and that this is an ongoing issue through the ship's life. And so it's not just a piece of dedicated documentation that comes on board when the ship's built. So I'll hand back to Yuris to complete our presentation.
Excellent. So this is the final part of our presentation. We are now going to talk about individual user development. So the system is installed on board, and the crew is using it and they learn about it. But what is very interesting and exciting when we work with Stena, we also seen this very closely, that they're very happy to innovate and use different things to improve safety and improve the life on board. So this is again something based on the feedback received on board from the crew, because they have to deal with it every day and they find it's quite difficult to work with. Therefore, understand that feedback and then make necessary improvements is very important. Again, highlighting the bespoke training. So training is very important, because this is one of the things we noticed, that training needs to be very much bespoke to the ship, but at the same time it could be shared within the fleet. Information sharing, certainly we can see that some crew members understand the system and they create their own little notes and share that information within the fleet, which is an excellent idea, and it's a very good platform to make sure that consistent improvement has done within the fleet. And again, responsiveness and changing the procedure if need be, that's also very important. When the system changes, when we have new things introduced, that needs to be reflected within the training program and procedures to make sure that it is consistent, to make sure the new crew coming on board understand the new procedures, to make sure they are safe and the ship is safe and the environment is safe. So that's the wrap up, I think. So we just want to say thank you for your attention, and I hope that you enjoyed it. And if you would like to contact us about this particular part of the project, our contact details will be there. And thank you, and thanks for visiting Lloyd's Register.
Yep. Okay, we hand back to you then.
Thank you very much. That's very interesting indeed. One little question. Will these guidelines, will they be available publicly also? You make a
yes.
public version?
Yes, that is the idea. This is they're supposed to be prepared in a generic format that they would be available publicly. Of course, it's all European Commissions.
Yeah.
So
as was introduced there in the north-south transfer, knowledge transfer side of things, and as we put in our final slide there, these are supposed to provide, or our intention behind this approach is to provide a starting point whereby a new user to a scrubbing system and of course a cleaning system would have a base document to work from in order to hone it up into their particular ship trade, their ship, the ports they call at, and the particular system they've got on board, and the particular way they have of operating on board. So indeed, yes, these are, should we say, the starter template, which then people can decorate with their own individual and particular details in order to make them work for them, part of this knowledge transfer.
Perfect. Thank you very much. We really appreciate that. Before I start that little film that you teased us about, I will just tell you how we take care of the sludge for Britannica and Hollandica. And that is that we have one company that is the collecting company, so to say, and they are called Renewi or Renewi maybe? Renewi. And they will collect the sludge and so on, and then they bring it to a company that is called Geocycle, And we have a short little film from Geocycle here, because there you can see what is actually happening with the sludge in the end, so to say. So please have a look at this.
Geocycle is a pre-treatment platform for industrial waste destined to be recycled in cement plants. In Greek, geo means earth and cycle evokes the cycle of life. Geocycle refers to our ability to transform waste into a safe and usable source. Geocycle, present in over 40 countries worldwide, offers companies a safe and effective solution for their waste management. Sludge from industrial wastewater treatment plants is stored, homogenized and shipped to the dryer crusher at the Åbo plant. Muddy, pasty waste is delivered in barrels or in bulk. After unloading, they are homogenized and shredded to obtain a compact consistency. An impregnation support, such as sawdust, is mixed with the waste mix in a blender innertized with nitrogen. A magnetic separator removes the ferrous materials before the mixture is screened several times. The fine impregnated sawdust is conveyed to the storage hall and the residue from screening is dispatched to a dedicated cement plant. Alternative fuels provided by Geocycle are injected directly into the kiln at a temperature of 2000 degrees centigrade. The organic fraction of the fuels prepared by Geocycle is completely destroyed by producing thermal energy, while the mineral fraction, close to the clinker composition, fully integrates the clinker crystal structure. This is where the recovery of waste that is pre-treated at Geocycle and then co-processed in cement plants really makes sense. There is no final residue. In addition, it provides a significant saving in raw materials and fossil fuels. Geocycle, a safe and responsible solution for industrial waste management and recycling in cement plants.
Okay.
All right. I hope that gave you a little final idea about what is really happening with waste. As you can see, there is nothing coming out in the other end of this treatments, which is quite great. I think it will end up in a vast building somewhere around in Rotterdam, I suppose. We are actually doing on our ship Stena Scandinavica here in Gothenburg. We are doing the same thing and collecting the waste here and also treat it in the same way. Now, this was the end of our presentations that we had planned for today. But we will sit here for a little while again. If somebody wants to write some more questions, we have got there have been quite a discussion going on here. Björn, can you say something about that?
Well, we have received a few questions here, a little bit about the suit. Maybe I should just clarify what we're trying to say is that the scrubber, of course, reduces the soot or the particle emissions compared to running high sulfur HFO, heavy fuel oil. quite significantly, and that is what we're also taking care of in the water treatment module. And the investigation shows that it's actually from a particulate emission perspective more beneficial to switch fuels than to scrub. We actually initially thought that we would at least be on par also on particulate matter, but it turns out, you know, in the number of the mass of the particles, really we are a bit higher after the scrubber with heavy fuel oil than running low sulfur fuel oil. So that is the conclusion from the study. But the primary target of reducing SOx emissions is more than well achieved, or we achieved.
I mean, that's really something that we can see is that scrubbers is extremely good at taking away the sulfur.
Yeah.
So the sulfur limits, they are lower than for low sulfur fuel.
So, and yeah, I could probably, or I don't know if anybody could tell what is more important from sort of environmental or health perspective, but well, there are several parameters to take into consideration, obviously, in this case. So, and other questions, I think that most of them have been pretty clearly answered in the live chat. Should you have anything else, as Per said, we will be here a couple of minutes more after the presentation is closed and answer anything that comes into the live stream.
And then if you have some further questions or thoughts when you were going to bed tonight or something, then you could write questions and you should send them to the same address as you got the invitation. So if you use the address stena@adsinsight.com, which is the one where you got the invitation from, and you can send your questions there, and then we will take care of them when they come in. And we will also present this chat that we had today, and if there come any further questions on our website. And I added the website address there. It's www.stenatechnik.com. So they can go in. They can also find the presentations that we had from the previous conferences that we had. So and you will also have the new presentations that we had today. So with that, I would like to thank you, everybody out there, for your interest, and with that we say goodbye for now. Bye bye.
Thank you.
Thank you.